Hello students, today I am going to explain to you part 2 of this question, right? Part 2 of this question, where I am going to explain to you C part, okay? C part completely, right? Yesterday we did part A and part B. So part A answer was 0.81 for boost in the third attempt, and part A second one was at least once in 6 attempts, right? So this was the answer. At least one boost in the 6 attempts. Part B said, explain why probability that the first boost occurs on the x section. So we got this answer, okay, and hence write down an expression in sigma notation for E of x. So we wrote that we know that xi pi is E of x. So therefore x is their number of attempts, p is probability of success, 1 minus p is probability of failure, right? So like that we got this answer. Now today I am going to explain to you, consider the sum of infinite C part. In C part, consider the sum of an infinite geometric sequence with first term A and the common ratio R, where modulus of R is less than 1. Now look here, this is an infinite geometric series, right? Infinite geometric sequence. In infinite geometric sequence, you know that the sum is given by A upon 1 minus R, right? This is the formula for the infinite geometric sequence when modulus of R is less than 1. So that is what is written here. Now they say that by differentiating both sides of above equation with respect to R, find an expression for this one, right? So look here, differentiating both sides, right? So d by dx of a plus ar square plus ar cube so on is equal to d by dx of a upon 1 minus r, or this can also be written as d by dx of a into 1 minus r to the power negative 1. This will be better, okay? Now look here, you know that how to differentiate it with respect to r. R is the variable here, right? We are going to differentiate with respect to r. So d by dr we want to do. So first term will go, a will become 0, ar will become ar square will become 2ar, ar cube will become 3ar square, and so on, right? And the right hand side will be a into, now the power will go to the left, minus 1 into 1 minus r to the power minus 2, right? So the answer is minus a upon 1 minus r, right? Bracket square, okay? Now this sum, and I have to write into minus 1 for the differentiation of minus r. So this sum will become positive, right? Okay, so this is what they said to show, right? So therefore sigma n is equal to 1 to r, 1 to infinity. This is an infinite geometric sequence. N a r to the power minus 1 is going to be equal to a upon 1 minus r bracket square, okay? So this is the answer of part A, part 1 of C, right? Because see, this is the differentiation what we have found. N is the number 1, 2, 3, 4. Look here, 1, 2, 3, 4. Like that we are going to get all the multiples from the power. So 1, 2, 3, 4, 5, 6, that is represented by n. Then a is already there, constant. A everywhere is constant, so that a is there. and r will have 1 power less. See, here it was 1 power, so no power. Here it was 2 powers, so 1 power. Here 3 powers, so 2 powers. So therefore it is 1 less than n, right? So here also you can compare. Here the multiple is 3, power is 2. Multiple is 2, power is 1. So with respect to n, the power is 1 less than n. That is why it is written like that, NAR raised to n minus 1, right? Now hence show that E of x is 1 upon p. You already know E of x means this is mean, right? Mu also we write it sometimes. You know that the formula for mean is E of x is equal to sigma xi pi. We used it in the last part also, in part A and in part B, right? Now here what we will do, we will take A is equal to P, the success, and R is equal to 1 minus P, the failure, right? And then we will write E of x from this one. So therefore E of x will be P into 1 upon 1 minus R is 1 minus P, failure, to the power 2, right? And when we simplify this, it will be P upon 1 minus 1, okay? 1 minus 1 will be 0, and minus and minus plus P, so P square. So finally we get E of x is equal to 1 upon P. Like this we get the answer of the second part, right? So I think this is enough for you. You can understand this. So I'll stop here and continue next time, maybe in the afternoon today. Okay then, bye.